Hello guys, welcome to Doctors of Medicine. I'm Yosu Wanzaje Zembwa, a user student. So today I'm going to take you through the physiology of the thyroid gland, where I'm going to take you through the physiologic effects of the thyroid hormone. So we start from the hypothalamus. The hypothalamus secretes what we call hypophysiotropic hormones. So it's going to secrete the thyrotropin releasing hormone. The thyrotropin releasing hormone, it goes to the anterior pituitary gland and it activates thyrotropic cells. These are chromophores. They are basophilic in nature. So these cells, they will secrete the TSH, the thyroid stimulating hormone. So from the word stimulating, it is going to stimulate what gland? The thyroid gland. It's going to stimulate the thyroid gland. So as it stimulates the thyroid gland is going to release three important hormones. It's going to release T4, the most abundant, T3, the most active. Out of T3, reverse T3, the inactive, it has no physiological effect. Now, so I want to see also that the thyroid gland, it contains cells. We have what we call follicular cells. These follicular cells, they can be simple cuboidal or a simple columnar, depending on the activation of this gland. So if the gland is activated, we are going to find simple columnar. If the gland is inactivated, you are going to find simple cuboidal cells surrounding the lumen. So these cells, they are surrounded by what we call parafollicular cells. They are also called C-cells, because they secrete calcitonin. What is the effect of calcitonin? Calcitonin decreases calcium concentration in the blood. Calcitonin, it decreases calcium concentration in the blood. It goes to the anterocytes and tells the anterocytes, do not absorb calcium. So calcium is going to decrease in the blood. It will go to the kidney and say, kidney, you need to wait. Do not reabsorb the calcium. So calcium is going to go through the urine, and then it will go to the bone, and then it's going to say, bone, you need to differentiate osteoblast to osteocyte, and also containing the calcium in the bone matrix. So it has effects of decreasing what? Calcium. So it is also produced by the thyroid gland. So now I want to see the synthesis of these hormones, the T4, the T3, and the RT3. Now, there are important things that are needed in the synthesis of thyroxine. Thyroxine, it requires thyroxine and iodine. So we are going to move through the pathways that will synthesize these hormones. So as we say that, we need iodine, we need thyroxine. So iodine plus thyroxine, it will give us thyroxine. Right. So the iodine in the blood, here, this is our blood vessel, maybe our capillary surrounding the follicular acini in the thyroid gland. So this blood vessel, it will contain iodine. So we have iodine. Where does iodine come from? It comes from the diet. The body cannot produce iodine. So it comes from the diet. And as now, when it moves from the GIT into the blood, it is bound to a protein called albumin. So albumin is going to carry, or is going to bind the iodide, and then it's going to bring this iodide to the thyroid gland. So the iodide, it has to get into the nucleus, because all the synthesis, the production of the thyroxine, it has to occur into the what? In the follicular acini. So we have a port here. We have a channel here. So this channel is called sodium iodide symport. Right. Sodium iodide symport. Sodium iodide symport, it's an active. It is an active secondary transport, whereby the gradient of the sodium We know that in the extracellular matrix, sodium is higher than in the intercellular matrix. So the gradient, that gradient, it is going to open this channel. And as it opens this channel, it is also going to give way for ions to get into the follicular cell through this symport. So symport, it just means that both of them, they are entering at the same time, simultaneously into the follicular cell. So when inside the follicular cell, we have an important enzyme that is called the thyroperoxidase. Thyroperoxidase. This is an important enzyme because it facilitates 3 important processes. We have oxidation, peroxidation, and coupling. So you just have to note that. The thyroperoxidase, it stimulates oxidation, peroxidation, and coupling. So we start from oxidation. Remember, we have iodides. We want iodine. So it's going to oxidize iodide to iodine by the process of oxidation. Now we have iodine. We said we need 2 things. We need the tyrosine and iodine to make the T4, T3, and RT3. So the iodine is going to combine with the tyrosine. So tyrosine, where does tyrosine come from? Tyrosine, it's an essential. It comes from an essential protein, essential amino acid. That is called phenylalanine. So phenylalanine is going to be broken down to tyrosine, and then the tyrosine is going to be bound by a beta globulin. Right? So we know that in the blood we have plasma proteins, and then we have beta globulin that is produced from the liver. So the beta globulin is going to bind tyrosine. What's the name of that beta globulin? It's thyroglobulin. So we say tyrosine plus thyroglobulin. We are going to have a complex here. I just resembled it as TG right here. So the TG, which is the thyroglobulin, is going to react with iodine. This process is called peroxidation, stimulated by what? By the thyroperoxidase enzyme. So peroxidation, we are going to add iodine to TG, the thyroglobulin, where we are going to form 2 complexes. We're going to form, if one iodine is bound to TG, we are going to form monoiodotyrosine. If 2 iodine bind to TG, we are going to form diiodotyrone. Right. So these are essential for the production of these hormones. So we need to go further and perform coupling. So we are going to join MIT, the monoiodotyrosine, DIT, the diiodotyrosine. As we combine them by the process of coupling that is stimulated by thyroperoxidase, we are going to form T3, T4, and RT3. But now it depends on whether MIT is going to bind to DIT, or DIT is going to bind to MIT, or DIT is going to bind to DIT. Right. So if MIT, the monoiodotyrosine, binds to DIT, the diiodotyrosine, we are going to have what? T3. T3, this 3, it resembles the amount of the number of iodine bound to the thyroglobulin. So if we have a T3, which means we have a 3 iodine bound. Right. So the complex will look like this. Something like this. Right? Whereby the TG here is MIT and DIT. So we have 3 iodine bound to this complex. And then how do we form T4? T4 is formed when we bind DIT plus DIT, the die, just 2 plus 2. So we have 4 iodine. That makes T4, right? So T4 is also called tetraiodothyronine. Tetra means 4. And then T3 is called triiodothyronine, which is because it has 3 iodine. So after we have formed these hormones, remember we are forming them in the lumen. This is the lumen, right? So they get into the follicular cell by the process of endocytosis, and then they move from the follicular cell into the blood. All right. So their effects, the T4 and the T3, they have physiological effects. So you need to know, like we have said here, the T4 is abundant. The T3 is not that abundant when they are produced by the thyroid hormone, but the T3 is more active than the T4. So the T3 has a shorter half-life than T4. Right. But we can also produce T3 from T4. So T4 acts as a reservoir, a storage unit of T3.